Hi everyone, thank you for coming to my talk. My name is Vaishali. I work at SUSE on confidential computing, and today I want to talk about adding monotonic timer support in COCONUT-SVSM. So here is today's agenda. I know some of you may have seen earlier KVM forum talks on COCONUT-SVSM, but for those who are less familiar, I'll go with the quick introduction, and from there I'll highlight the motivation and need for the monotonic timer. After that, before we look into the solutions, I also want to go quickly through the timekeeping that has been done in the non-COCO VMs. And after that, we'll go through the secure timer sources with the COCO platforms, and then the hybrid approach that we are considering to add in the COCONUT-SVSM. So, quick introduction. COCONUT-SVSM, SVSM stands for Secure Service Module. It's a software which aims to provide secure services and device emulations to guest operating systems, especially in the confidential virtual machines. The project started with a collaboration between SUSE and AMD when AMD introduced virtual machine privilege levels as part of the SEV-SNP. The idea is that you have some of these services running at the higher privilege levels within the same guest instead of hypervisor. Some of these services include virtual TPM emulation, UEFI variables, live migration, etc. The project now has a growing support for Intel TDX partitioning as well, and also for non-confidential virtual machines. So if we zoom in a bit into COCONUT's architecture at the moment, we have a distinction between user space and kernel space. Over the last year, a few things have already been added in the user space. So the idea is that COCONUT-SVSM's user space will have those services and the modules that provides the services to the high level. This includes a heap allocator for the memory management, syscalls for interacting with the SVSM kernel, also file system support. We are also planning to have a IPC and event delivery framework to enable the communication between the modules and also the COCONUT kernel and the user space services. I won't go much deeper into the updates with regards to what we have now already since last year, because that will be covered by Stefano and Oliver in the next talk. But as these building blocks are accumulating and as the SVSM's user space is maturing, there's a growing need for integrating Rust STD library. So, and this is useful for providing the richer abstractions for building the services. So those who are not aware of the Rust ecosystem, Rust standard library has 3 layers. We have got core, alloc, and STD. Core provides you the minimal no-heap foundations and includes the very minimal types, traits, module support. After that, you have alloc, which is a heap allocation without the OS. It enables the dynamic memory types like vec, string, also the reference typing related types, RC, ARC, etc. And then you have the full standard library with OS integration related modules, also file system, networking, concurrency, timer related stuff. And these are all like adding platform dependent capabilities. So to be able to build these services, we need Rust STD in COCONUT-SVSM. And one of the main things where this is required is the time module. It has instant struct. Basically, This instance struct within the time module requires a monotonic timer support because it does the measurement of a monotonically non-decreasing clock. And adding a support for STD will also unlock wider Rust ecosystem for Coconut's user space, especially those crates which are using the STD-based stuff, right? And to bring the Rust STD support, the plan is to also add COCONUT-SVSM as a tier 3 target, and then go upwards from there. So other use cases, so that's like a primary use case why we want the monotonic timer sources, but there are some other use cases as well which are in the discussion. It may or may not be used, and I just wanted to mention some of them. So for example, lately there have been some reports about long-running TPM operations and the TPM calculations where guest OS has a soft lock, and this delays can trigger the kernel panics in the kernel OS. So here one of the possible solution could be timer interrupt. We don't have to go for it, but it's one of the possible solutions that has been discussed in the community. Another thing is that one of the longer term goal for COCONUT-SVSM is also to emerge as a paravisor, which means that there may be a situation where we would like to emulate the timer, and the guest OS can then use Coconut timer sources. Another thing, there is a student project where they are adding a TCP/IP, like a very minimal TCP/IP stack inside the kernel space of the Coconut at the moment, because the user space is not that mature yet. But the idea would be to move it to the user space, and this is basically used for the remote attestation, and for this also having a monotonic timer source will be useful, right? Before we dive into the solutions, let's understand what we have got in the modern Linux. I'll mostly talk about within the scope of this talk, so I'm not gonna cover everything. So modern Linux runs, especially on the x86, it runs in the tickless mode, which means that it doesn't rely on fixed periodic interrupts, right? So rather it uses a monotonic counter like TSC, timestamp counter, which is incremented for the every time unit that has elapsed since boot. This counter can be read when required. TSC basically is a model-specific register that keeps the count of the processor clocks, processor clock cycles. And in x86, we have got RDTSC and RDTSCP instructions, which are used to read TSC. So when it comes to virtualization world and the non-COCO setup, hypervisors can intercept RDTSC and RDTSCP. So for example, let's say we talk about the AMD platforms. If a VM executes RDTSC instruction to measure the elapsed time, like for the timeout or for scheduling, etc., KVM controls the VMCB, and it can intercept RDTSC. On interception, the CPU traps into KVM instead of like letting the VM read the real hardware TSC. And even if hypervisor chooses not to intercept these instructions and let the VM access the TSC, the hypervisor still has an access, and it can write to the TSC MSR and basically controls the VM's view of the TSC. I'll talk a bit later about what are those values which hypervisor can control. But another thing that KVM has got is a paravirtual clock, KVM clock. It is exposed by KVM ioctls, get clock, set clock. It provides the constant notion of the time across vCPUs. And then it basically uses the KVM system time new MSR It's mainly a handshake point between the guest and the hypervisor for setting up the KVM's paravirtual clock using the 64-bit address to store the vCPU time info. I think they had one of the old one, which was the 32-bit address, and this is the new one, which is recommended to use. So what do we have with respect to secure time or sources on COCO platforms? So I'll mostly cover only x86 here. So if we talk about TSC in AMD SVM, so AMD SVM has two parameters, TSC ratio and TSC offset. And that basically controls the VM's view of the TSC. The value in the TSC ratio, MSR scales the TSC value when VM reads the TSC. This is particularly useful when a process in a VM moves between the cores that runs at the different frequencies. VM writes to the TSC via WRMSR are intercepted and instead emulated by offsetting the value in the TSC offset. TSC reporting is hypervisor controlled, as I mentioned before, especially because the TSC ratio and TSC offset are part of the VMCB, which is under the hypervisor's control in the non-COCO platforms. So with the SEV-SNP, what has been done is that now the TSC scale and TSC offset are part of the VMSA page, which is within the guest and encrypted one. So what was used to be part of the VMCB within the hypervisor is now kind of moved into the VMSA page. And TSC value is basically calculated with guest TSC scale into TSC row and with addition to guest TSC offset. So how the flow works in SEV-SNP is that it has a filled desired TSC for the SNP launch start. Once the guest has been launched, this value is copied into an encrypted and integrity protected page. Guests that run with SecureTSC enabled may read the guest TSC frequency MSR. This is the new one being added with the SEV-SNP, and it's a read-only MSR. It returns the effective frequency in megahertz of the guest's view of TSC. Guests are not supposed to write to SecureTSC. RDTSC interceptions are prevented by the VC handler. Even if guests somehow end up writing to the SecureTSC, the subsequent values by guests, the subsequent values of the read are undefined then. So what are some of the limitations here? One of the things is that in an actual chip, there is a tiny difference between the advertised P0 frequency and the actual TSC frequency. Frequency reported by SecureTSC is a P0 frequency, and the tiny difference, usually 0.2%, causes a clock skew over time between the hypervisor and the SNP VM. This is due to spread spectrum clocking. Spread spectrum clocking is a hardware technique that is used to reduce EMI, electromagnetic interference, from digital systems. So the clock frequency is slightly modulated. One of the important things to mention here for AMD platforms is when a guest creates its own VMSA, it queries the PSP for information with the TSC info message to determine the correct values to write into the TSC scale and TSC offset, as we saw, which is part of the VMSA. TSC scale and TSC offset are the values which they get from the TSC info message. TSC info also has the TSC factor, and TSC factor has the encoding of the percentage decrease from the nominal TSC frequency to the mean TSC frequency due to clocking parameters. So, for example, a TSC factor value of 200 indicates a reduction of 0.2% from nominal TSC frequency. This is part of the firmware ABI specification. So, what about Intel? So in COCONUT-SVSM, TDX partitioning is still emerging. But just to mention that in general, Intel TDX also has a limited secure time with the TSC timer. The TSC inside a TD is guaranteed to be synchronized and monotonous, but not necessarily matching the real time. A guest can turn it into a secure, truly secure wall time by using a remote authenticated time server via NTP. That's the recommended way over there. So why hybrid approach? So as COCONUT-SVSM as it is now, one of the main reasons as we have is Rust STD. And for that, on the COCO platforms, it can do with the secure timer sources that are provided by the platforms, right? But we also have non-COCO platform support, which is particularly useful for debugging and also makes it usable with VSMs. So for that, we anyway need something else. And the solution here could be to go with the KVM clock. And then when we reach at the use cases where we need where the correction matters more, then we could use an approach where we compare the values reported by both KVM clock and secure timer sources, and then if they are close enough, we go with the value with the KVM clock one to avoid the correction related issues. So how would KVM clock and COCONUT-SVSM would work? So this is something that is still in the discussion, but I had some discussions with the maintainers yesterday, and I also invite you all to discuss if you have any concerns, comments, suggestions. There are three approaches we can do. One is we have single KVM clock instance for all VM planes, and plane 0 initiates so at the COCONUT-SVSM level, it's initiated at the plane 0, and then plane 0 makes it read-only for all the VMPL 1, 2, etc., higher privilege levels. This will, of course, require also the changes in the SVSM protocol. Second option would be multiple KVM clock instances. So each plane has a copy of it and its own copy of the structure data, and it just maintains by its own. We'll have to see how much synchronization we will have to do in between the planes, but that's the second approach. And the third would be to implement COCONUT-SVSM's own para-virtualized clock driver. For now, based on the discussions yesterday, I'm going to go with the first one, since it's like one of the preferred approach by the KVM maintainers, and then we will see how it goes from there. So yeah, that's mostly about it from me. If you have any questions, suggestions, you're welcome to speak. You can come also. It's okay. So his question is, well, the first one was who will initiate it, right? And from the hypervisor, and then who will make sure that it's read-only. Yeah, so right now I think it can be done within the guest at the plane 0 level, but we'll have to see.
Because it would need to be a shared page is not usually.
Yeah. Ah, okay, with the hypervisor, you mean?
No, like on the also lower plane. Like,
right.
because for private pages you can set up permissions, but you can't do that for the lower levels. So I'm not sure how you bring it over.
Okay. So you mean this has to be done by the hypervisor to enforce that it's only read-only for all the other all the other planes?
I don't think that's what we should do, but I don't see how we can do it inside the guest. Yeah, maybe that's an issue.
Yeah, I think this is another problem. If you don't trust the hypervisor, can you trust the KVM clock provides?
Right, but if it's set by the guest at the plane 0 level, then
yeah, but the hypervisor is providing the KVM clock details, basically.
yeah. So in the case of COCO platforms, obviously the idea is to match the values, right? And if they are close enough, then only we use the KVM clock one. So mainly for the non-COCO platforms, right? Because non-COCO platforms don't have any secure timer sources. So how are they going to use it? So for that, we need some timer source, and that will be KVM clock at the moment.
Never use the KVM clock for anything. It never gives you anything that the TSC doesn't. Unless you're on ancient hardware where the TSC doesn't go in.
So your
Yes, there are also, besides what she talked about, there's also a second part of the KVM clock, which gives you basically the whole-time clock basis. So basically the second where you got the boot of the VM.
There is a separate KVM clock.
There's a separate
KVM clock.
Yes, and then I think the whole-time clock is actually more important than the actual KVM clock.
The wall-time clock is an abomination, and it gives you the epoch in terms of the KVM clock, which isn't NTP skewed anymore, even though it was a decade ago. Don't use it.
You need something to bootstrap until you bring up NTP.
Sorry?
You need to bootstrap the whole thing until you bring up NTP.
You need VM clock, which is the thing that Kieran will now advertise. It is essentially like a VM, like a KVM clock, except it gives you current microsecond precision time according to your TSC. The KVM clock will give you nothing. If you want wall clock time, come up with a way of trusting the VM clock structure, which gives something to trust again.
okay, yeah, I'll look into it. Thanks.
Yeah, but how do you verify the data you got from the hypervisor? Because if you don't have any NTP source, you can't say they have close enough one.
Because there's no information. KVM clock doesn't have information.
Yeah, right.
You don't have to trust it because it doesn't give you anything.
Yeah.
But yes, if it was giving you useful information, that would be an interesting question.
Yeah, so if it's giving you one clock time, so we have to trust it or not. So you have no way to verify without having the trust time.
Right, but on the case of the non-COCO platforms, we assume that it's not secure, right? It's not a COCO platform that you are running it on. It's mostly for the debugging and also for some other use cases. So. Okay, thank you then.